When relocating an existing 25 kV UPS system for a computer network, several National Electrical Code, or NEC, articles should be observed to ensure a safe and compliant installation, particularly within an IT server room environment. Article 480 covers storage batteries, addressing the installation and safety requirements for batteries used in UPS systems, including ventilation, proper terminations, and overcurrent protection. Article 645 specifically deals with information technology equipment, encompassing power distribution, disconnecting means, grounding, and wiring methods unique to IT equipment installations including UPS systems. Article 702 pertains to optional standby systems, covering generators and other standby power sources, and also provides guidance on the proper installation and connection of UPS systems used as backup power. Other articles should also be considered for your specific situation. Article 692 addresses the requirements for solar photovoltaic, or PV, systems, and if the UPS is integrated with the PV system for energy backup or grid interaction. This article becomes relevant, covering wiring methods, disconnects, overcurrent protection, and grounding specific to PV installations. Article 725 covers Class 1, Class 2, and Class 3 remote control, signaling, and power-limited circuits, addressing wiring and protection methods for low-voltage control and signaling circuits often found in UPS systems for remote monitoring and control functions. Article 770 covers optical fiber cables and raceways, which is important if the UPS system utilizes fiber optic communication cables for data transmission or remote monitoring, detailing proper installation and separation from power conductors. Article 800 covers communication circuits, which are important if the UPS system has communication connections for remote monitoring, control, or data logging, ensuring proper separation and protection of communication wiring from power conductors. It's important to also consider specific requirements for UPS systems that are found within the NEC. Article 645.12 states that UPS systems must be listed for use with electronic equipment and have a minimum voltage distortion rating of 5%. Article 645.15 states that UPS systems must be grounded and bonded according to Article 250, ensuring a safe and effective ground fault path. Article 645.18 covers the need for batteries for UPS systems to be installed in a ventilated enclosure, which is very important to prevent the accumulation of explosive gases. Article 702.12 states that UPS systems must be installed in a location that is accessible for maintenance and protected from damage. Finally, Article 702.37 requires UPS systems to be installed in a manner that maintains the integrity of the electrical system and prevents the spread of smoke or fire. To elaborate further on these articles, let's begin with Article 480, which is crucial for UPS installations because these systems invariably involve batteries. This article provides comprehensive guidelines for the proper installation and maintenance of storage batteries to minimize potential hazards. One key aspect of Article 480 is ventilation, as batteries, particularly lead-acid batteries, can emit hydrogen gas, which is explosive. Section 480.10 addresses ventilation requirements, mandating sufficient airflow to prevent the accumulation of hydrogen gas. This can be achieved through natural ventilation, such as openings to the outside, or mechanical ventilation, such as exhaust fans. The specific ventilation requirements depend on the type and size of the battery system. Another important consideration is overcurrent protection. Section 480.9 requires batteries to be protected against overcurrent to prevent fires and explosions. This protection can be provided by fuses or circuit breakers installed in the battery circuit. The size of the overcurrent protection device must be appropriate for the battery's ampacity. Proper terminations are also essential for safe and reliable battery operation. Section 480.4 covers terminations, requiring them to be made with listed connectors and terminals suitable for the type of battery and conductor material. Terminations must be clean and tight to minimize resistance and prevent overheating. Furthermore, Article 480 addresses the spacing and arrangement of batteries. Batteries must be arranged to allow for adequate access for inspection and maintenance. They must also be protected from physical damage and accidental contact with conductive objects. In addition to these general requirements, Article 480 includes specific provisions for different types of batteries, such as lead-acid, nickel-cadmium, and lithium-ion batteries. These provisions address the unique characteristics and hazards associated with each battery type. Moving on to Article 645, this article is specifically tailored to information technology equipment, making it highly relevant to UPS installations in IT server rooms. Article 645 addresses several key aspects of IT equipment installations, including power distribution, disconnecting means, grounding, and wiring methods. Power distribution is a critical consideration in IT server rooms due to the high density of electronic equipment. Section 645.5 allows for the use of flexible power cords for connecting IT equipment, provided that the cords are not longer than 15 feet and are protected from physical damage. However, the article also emphasizes the importance of providing adequate overcurrent protection for branch circuits supplying IT equipment. Disconnecting means are essential for safely de-energizing IT equipment for maintenance or emergency purposes. Section 645.10 requires disconnecting means to be readily accessible and clearly marked. The disconnecting means must be capable of disconnecting all power to the IT equipment. Grounding is another critical aspect of IT equipment installations. Section 645.15 requires IT equipment to be grounded in accordance with Article 250, which provides comprehensive guidelines for grounding electrical systems. Proper grounding helps to minimize the risk of electric shock and prevent equipment damage. Wiring methods in IT server rooms must be carefully selected to ensure safety and reliability. Section 645.6 restricts the use of certain wiring methods, such as flexible metal conduit, in underfloor spaces used for environmental air. The article also requires cables to be securely supported and protected from physical damage. Article 702 is applicable when the UPS system is intended to provide backup power in the event of a power outage. This article covers optional standby systems, which are systems that are not legally required but are installed to provide power for specific loads during a power outage. Article 702 addresses several key aspects of optional standby systems, including transfer equipment, wiring, and overcurrent protection. Transfer equipment is used to automatically switch the load from the normal power source to the standby power source in the event of a power outage. Section 702.5 requires transfer equipment to be suitable for the intended application and to be installed in accordance with the manufacturer's instructions. The transfer equipment must also be capable of transferring the load back to the normal power source when power is restored. Wiring for optional standby systems must be carefully selected to ensure safety and reliability. Section 702.9 requires wiring to be sized to carry the maximum load that will be connected to the standby power source. The wiring must also be protected from physical damage and installed in accordance with the applicable requirements of Chapter 3 of the NEC. Overcurrent protection is essential for protecting the standby power source and the connected loads from overloads and short circuits. Section 702.16 requires overcurrent protection to be provided for the standby power source and for each branch circuit supplying a load connected to the standby power source. The overcurrent protection devices must be sized in accordance with the applicable requirements of Article 240. Now let's consider Article 692, which is relevant if the UPS system is integrated with a solar photovoltaic or PV system. This article provides comprehensive guidelines for the installation of PV systems, including wiring methods, disconnects, overcurrent protection, and grounding. Wiring methods for PV systems must be carefully selected to ensure safety and reliability. Article 690.31 specifies the types of wiring methods that are permitted for PV systems, including Type Use 2, which is a sunlight-resistant cable specifically designed for PV applications. The wiring must be installed in a neat and workmanlike manner and must be protected from physical damage. Disconnects are essential for safely de-energizing PV systems for maintenance or emergency purposes. Article 690.13 requires disconnects to be readily accessible and clearly marked. The disconnects must be capable of disconnecting all power from the PV system. Overcurrent protection is essential for protecting the PV system and the connected loads from overloads and short circuits. Article 690.9 requires overcurrent protection to be provided for the PV source circuits and for the output circuits of the PV system. The overcurrent protection devices must be sized in accordance with the applicable requirements of Article 240. Grounding is another critical aspect of PV system installations. Article 690.41 requires PV systems to be grounded in accordance with Article 250. Proper grounding helps to minimize the risk of electric shock and prevent equipment damage. Article 725 covers Class 1, Class 2, and Class 3 remote control, signaling, and power-limited circuits. These circuits are commonly used in UPS systems for remote monitoring, control, and signaling functions. Article 725 addresses several key aspects of these circuits, including wiring methods, overcurrent protection, and voltage limitations. Wiring methods for Class 1, Class 2, and Class 3 circuits must be carefully selected to ensure safety and reliability. Article 725.25 specifies the types of wiring methods that are permitted for these circuits, depending on the voltage and current levels. The wiring must be installed in a neat and workmanlike manner and must be protected from physical damage. Overcurrent protection is essential for protecting Class 1, Class 2, and Class 3 circuits from overloads and short circuits. Article 725.23 requires overcurrent protection to be provided for these circuits, with the size of the overcurrent protection devices limited by the class of the circuit. Voltage limitations are also important for Class 2 and Class 3 circuits. Article 725.21 limits the voltage of Class 2 circuits to 30 volts alternating current or 60 volts direct current. The voltage of Class 3 circuits is limited to 150 volts alternating current or 300 volts direct current. Article 770 addresses optical fiber cables and raceways, which are used in some UPS systems for data transmission or remote monitoring. This article provides guidelines for the proper installation and separation of fiber optic cables from power conductors. Article 770.6 specifies the types of raceways that are permitted for optical fiber cables, including rigid metal conduit, intermediate metal conduit, and electrical metallic tubing. The raceways must be installed in accordance with the applicable requirements of Chapter 3 of the NEC. Separation of optical fiber cables from power conductors is essential to prevent interference and ensure signal integrity. Article 770.55 requires optical fiber cables to be separated from power conductors by a minimum distance of 2 inches, or by a barrier. Article 800 covers communication circuits, which are used in some UPS systems for remote monitoring, control, or data logging. This article provides guidelines for the proper installation and protection of communication wiring. Article 800.24 requires communication wiring to be separated from power conductors by a minimum distance of 2 inches, or by a barrier. This separation helps to prevent interference and ensure signal integrity. Communication wiring must also be protected from overvoltage and overcurrent. Article 800.100 specifies the types of protection devices that are required for communication wiring, depending on the voltage and current levels. In addition to these general requirements, the NEC includes specific provisions for UPS systems. Article 645.12 requires UPS systems to be listed for use with electronic equipment and to have a minimum voltage distortion rating of 5%. This requirement ensures that the UPS system is compatible with the IT equipment that it will be powering and that it will not introduce excessive harmonic distortion into the electrical system. Article 645.15 requires UPS systems to be grounded and bonded in accordance with Article 250. Proper grounding and bonding are essential for minimizing the risk of electric shock and preventing equipment damage. Article 645.18 requires batteries for UPS systems to be installed in a ventilated enclosure. This requirement helps to prevent the accumulation of explosive gases and to ensure the safe operation of the battery system. Article 702.12 requires UPS systems to be installed in a location that is accessible for maintenance and protected from damage. This requirement ensures that the UPS system can be easily accessed for routine maintenance and repairs and that it will not be damaged by environmental factors. Finally, Article 702.37 requires UPS systems to be installed in a manner that maintains the integrity of the electrical system and prevents the spread of smoke or fire. This requirement ensures that the UPS system will not compromise the safety of the building or its occupants. To summarize, when installing a UPS system in an IT server room, it is essential to observe the requirements of Articles 480, 645, 702, 692, 725, 770, and 800 of the National Electrical Code. These articles provide comprehensive guidelines for the safe and reliable installation of UPS systems, ensuring that they will provide backup power when needed and will not pose a hazard to people or property. By following these guidelines, you can ensure that your UPS installation is compliant with the NEC and that it will provide years of trouble-free service. Always consult with a qualified electrical contractor or engineer to ensure that your UPS installation meets all applicable requirements. It is important to note that the NEC is a complex and constantly evolving document. It is essential to stay up to date on the latest revisions to the NEC and to consult with a qualified electrical professional to ensure that your electrical installations are compliant with all applicable requirements. The NEC is not a substitute for proper training and experience. Electrical work should only be performed by qualified individuals who have the necessary knowledge and skills to perform the work safely and effectively. It is important to use caution when working with electricity. Electricity can be dangerous and can cause serious injury or death. Always follow safe work practices and use appropriate personal protective equipment when working with electricity. If you are not comfortable working with electricity, you should hire a qualified electrical contractor to perform the work. It is also important to remember that electrical codes and regulations vary from jurisdiction to jurisdiction. Be sure to check with your local electrical inspector to determine the specific requirements that apply to your electrical installation. By following these tips, you can help to ensure that your electrical installations are safe and compliant with all applicable requirements. Safety is always the top priority when working with electricity. Take the time to learn about the hazards of electricity and how to work safely. Always follow safe work practices and use appropriate personal protective equipment. If you are not sure how to do something safely, ask for help from a qualified electrical professional. When installing a UPS system, it's important to consider the specific needs of the IT equipment that it will be powering. The UPS system should be sized to provide adequate power for all of the connected equipment and should have sufficient runtime to allow for a graceful shutdown in the event of a power outage. It is also important to consider the environmental conditions in the IT server room. The UPS system should be installed in a location that is protected from extreme temperatures, humidity, and dust. The UPS system should also be properly ventilated to prevent overheating. Regular maintenance is essential for ensuring the reliable operation of the UPS system. The batteries should be checked regularly and replaced as needed. The UPS system should also be inspected for any signs of damage or wear. By following these maintenance tips, you can help to extend the life of your UPS system and ensure that it will provide backup power when needed. The selection of a UPS system should be based on a careful assessment of the power requirements of the IT equipment that it will be powering. It is important to consider the total power consumption of all of the connected equipment, as well as any future expansion plans. The UPS system should be sized to provide adequate power for all of the connected equipment, with some margin for future growth. The runtime of the UPS system is another important consideration. The runtime is the amount of time that the UPS system can provide power to the connected equipment in the event of a power outage. The runtime should be sufficient to allow for a graceful shutdown of the IT equipment, or to allow for the orderly transfer of operations to a backup power source. The type of UPS system is also an important consideration. There are several different types of UPS systems available, including online, offline, and line interactive UPS systems. Online UPS systems provide the highest level of protection, but they are also the most expensive. Offline UPS systems are the least expensive, but they provide the least amount of protection. Line interactive UPS systems offer a good balance of protection and cost. The features of the UPS system are also important to consider. Some UPS systems include features such as automatic voltage regulation, surge protection, and remote monitoring. These features can help to improve the reliability and performance of the IT equipment. The cost of the UPS system is always a consideration. However, it is important to balance the cost with the level of protection and features that are required. It is often worth spending a little more to get a UPS system that will provide adequate protection and features for the IT equipment.